All right, let's consider this one here now for our rational functions. A little more complicated, but and that's because look at what I've got for vertical asymptote here. Denominator equals 0. And so that's going to turn out 2. We're going to have 2 vertical asymptotes because this does factor 2x and x, minus 3 and positive 1, like that. Yeah, because that and that's minus 6x, and that and that's positive 1x. Yeah, that gives us the correct middle term. So, yeah, we've got 2 vertical asymptotes in this case, where 2x plus 1 equals 0 and x minus 3 equals 0. So that's minus a half and positive 3. So I've got two vertical asymptotes. So that's obviously going to complicate things a little bit. All right, now the horizontal asymptote. Well, we have a similar situation here, I think, as the last one I did, because for this to work, you have to have matching degrees. And the bottom degree is, the leading term there is 2x squared. The top doesn't have an x squared, but we can fix that and make it a 0x squared. And so once again, by elimination there, our horizontal asymptote will be 0 once again. Okay? Let's put those up here. Minus a half, vertical asymptote, so that's going to be a dotted line, and then positive 3, so another vertical dotted line like that, and then y equals 0, horizontal line at 0, because that's our horizontal asymptote. So far, so good. We good? All right. What about the intercepts? The y-intercept, same old, let x be 0. So it'll be 0 plus 5 over 2 times 0 squared minus 5 times 0 minus 3. Well, that's going to be positive 5 over negative 3. Negative 1, 0.6 repeating. We do it as a decimal. Right? What about the x-intercept? Well, the x-intercept, the y is 0, or f of x is 0. But that's really not that bad because multiply both sides by 2x squared minus 5x plus 3. It's just x plus 5 equals 0. So that's x is negative 5. So the x-intercept's negative 5 and y-intercept's negative 1.6 repeating. So I cross the y-axis at negative 1.6 repeating, and x-intercept, so across the x-axis at negative 5. Which you might notice there is right on the horizontal asymptote. So I'll say a little more about that in just a second. What's going to happen there? All right. But that's still just a couple of points. I would strongly suggest have you do a couple other points here. So again, the x values for my table, values around the vertical asymptote. So yeah, let's throw in here negative, was that negative 2 and negative 1? And then around this one, let's also go 1 and 2. Yeah, since we've got 2 vertical asymptotes, that makes the table. Probably do a couple more on the table, and then that's 4 and 5. Let's do 4 and 5 also. Just to kind of give us a feel for what's going on here. All right, so let's see if we can get those cranked out here pretty quick. So we plug in negative 2 plus 5. Plug in negative 2, that'd be 2 times 4, so that'd be 8. Minus 5 times negative 2 would be positive 10. Minus 3, so we got 3 over 15. I believe. Is that right? 3/15, 1/5, 0.2. X is negative 1, so it'll be negative 1 plus 5. over negative 1 squared is positive 1, so it'll be 2. Negative 1 times negative 5 is positive 5, and then minus 3, so that's 4 over 4. That's 1. So negative 1, we got positive 1. All right, now we got positive, so maybe that's a little easier. 1 plus 5, so that's 6. X is 1, so that's 2 minus 5 minus 3. All right, what does that give me? 6 over negative 6, I believe. Negative 1, we gotta believe that? Is that okay? X is 2, so I have 7 over 2 times 2 squared, so that's 8. Negative 5 times 2, that's negative 10 minus 3, so that's 7 over negative 5. Question? Negative 1.4. Then 4, we got 9 over 2 times 16, so that'd be 32. Minus 20, minus 3. 9 over 9, right? Just 1. And then 5, we've got 10 over 2 times 25, so that's 50. Minus 5 times 5, that's 25, minus 3, so that's 10 over 22. Five elevenths. Yeah. All right, so that's some good points there. Let's graph. Is that okay? Any of those look wrong? Believe those? All right, so at negative 2, I'm just at 0.2, so it's not very much off the x-axis there. At negative 1, I'm at 1. At 1, I'm at negative 1. Right there. At 2, I'm at negative 1.4. At 4, I'm at 1. And at 5, I'm at 5/11, which is a little bit more than a half. I didn't get the decimal, but somewhere along there, along a half-ish. Okay. All right, so then we do this. Let's see. Okay, well, connect the dots over here. The basically one thing the asymptotes do is they divvy up the graph into parts. And so this graph has 3 parts. We got a part to the left over here, we got a part in the middle, and a part to the right. Because the vertical asymptotes will break it up that way. Now, what does it seem like it's doing as we go towards the vertical asymptote here? Is that negative a half? It's going up, yeah. It's like this graph's going up. In here, well, I've kind of got an arch going on there. Because it goes from here up a little bit, because that's at negative 1. This was at negative 1.6. And then it goes back down to negative 1.4. So it looks like, if you need more, we could do like a 2.5 to see if we needed more confirmation of this, and maybe a point between 0 and minus a half if you need to, but it can't go back up. You see that? Why do I know it can't go back up? There's only one x-intercept. There's not an x-intercept here. So it's not going back up in here. Yeah, it's down on both sides here. So that's a little different than we've seen.
What about your other points?
What other points?
4 and 5.
4 and 5? Yeah, well that was in here. So I'm doing this part, then this part, and this part. Like I said, it's 3 different parts. Yeah, you got 3 different parts. Yeah, so now we have that third part to the right. All right, so these points, what does that seem to be telling you? As far as going towards the asymptote here. Up, right? General direction's up. So that just leaves kind of the ends. Well, the ends, this is your end behavior. The horizontal asymptote is 0. So it's going to level off at 0 out here. Which brings us to the other side of it for last here. Notice I connected it up because that is my x-intercept right there. an x-intercept is where it crosses the x-axis. So we're crossing the x-axis here, unless it bounces back up above the x-axis. But I believe here we are going to cross the x-axis. Now, I cross the x-axis, but what's happening on the ends? Well, it's still leveling off at 0, so it just kind of doesn't go anywhere. It just kind of levels off after you go across it there. And if you wanted to see, I mean, we could check your negative 6 point. It's going to be negative if you plug it in. So it does cross there. But it levels off at 0, so it just kind of hangs out, levels off at 0. Which brings up a point. We cannot cross a vertical asymptote, right? Because that's by very design of the equation. Because that denominator 0 you can't have. Can we cross the horizontal asymptote though?
Yes.
We just did, didn't we? Here's an example. You can cross a horizontal asymptote. It happens sometimes. It doesn't happen a lot, but you can cross a horizontal. It's just a different thing. So if you cross a horizontal asymptote, don't sweat it, because you can do that. Those can intersect those. Horizontal asymptotes are just about the end behavior. Vertical asymptotes are where the function doesn't exist. It's undefined. So that's why you can't cross those. Horizontal asymptotes, though, that's okay to cross those. And probably we'll have a couple of them where that happens. But here's one example. Anything else? Any further questions? Cause for concern? Look okay? All right. One more here of these. F of x equals 2x squared minus 8 over x squared minus 6x plus 9. All right. So a vertical asymptote here is denominator equals 0. Which looks like there might be 2, but what happens here? X, how's this factor? X minus 3 and x minus 3, isn't it? And so actually, both of those are the same. So we got just one. Both of them are x equals 3. So there's really just one vertical asymptote. Horizontal asymptote. All right, so that's, we do our y equals a over b thing. A and b are just the leading coefficients. So you got 2x squared over x squared. We have matching. As long as those are equal, this works. So 2x squared over x squared. Yeah, that's just going to be 2. Y equals 2. Put those up here. 3? Yeah, 3 is the vertical. 2 is the horizontal. The intercepts, well, the y-intercepts where x is 0, so that's 0, that's 0, that's 0, so it's negative 8/9. The x-intercept is where f of x equals 0, the y. But cross multiply or multiply both sides by x squared minus 6x plus 9. It's really just solving 0 equals 2x squared minus 8. Which does factor. For one thing, you got let's just do it this way. So we got add 8 and divide by 2. So you got x squared equals 4. So what is that?
2.
2 and
Negative.
negative 2. Yeah, plus or minus 2 because it's plus or minus the square root of 4. That's what solutions we have there. So those are my intercepts. The y-intercept's negative 8/9 and positive and negative 2 for the x-intercept. So here and here. So that's good. Little table, values around the x vertical asymptote. Well, I've already got around the vertical asymptote, so around x equals 3, sorry. That's what I'm doing for my x values. The vertical asymptote is 3. So I've got 2. I might, just to be sure here, I might go ahead and try something a little closer to it, like 2.5. Since I've already got 2, let's do 2.5. And on the other side, let's go 4 and 5 again. Because that'll give me a couple over here and a couple over there. That's what I'm shooting for. All right, so 2.5, x is 2.5, what do we got? So it's 2 times 2.5 squared minus 8, so the top's going to be positive 4.5. Over the bottom will be 2.5 squared minus 6 times 2.5 plus 9.25. So you got 4.5 divided by 0.25. 18. And then at 4, all right, a little easier. 32 minus 8 be the top. The bottom be 16 minus 24 plus 9. That's 24 over 1. 24. Is that right? And then at 5, we've got 2 times 5 squared, that'll be 50. 2 times 25, 50 minus 8, and then bottom we have 25 minus 30 plus 9. That's 42 over 4. 10.5. Those right? Did I do those right? Okay. Yeah, so this one brings up another little point about this. Look at what's happening. I've got a 2.5. It's up here at 18. Where's that stuff there? All right, let's call that 18. All right, so at 2.5, I'm at 18. Which is just on this side of the vertical asymptote. At 4, I'm at 24, so it's even further up, but it's up here 24. And at 5, I'm at 10.5, so let's say there's 10, so it's right about there. Okay, so connect the dots over here. Definitely going up here. And same thing here, isn't it? Definitely going up there. What's different about that one is, both sides of this one's going up, isn't it? Previously we had one going up, one going down, but that doesn't always happen. Sometimes you can get both sides at an asymptote going up, or both of them going down. So don't always assume they're alternating there. All right, so the other thing is, so if we connect the rest of it, what happens to the rest of it? Well, that's where the horizontal asymptote comes in, right? On the ends, it's got to level off at that horizontal asymptote, and so here we go. So it's coming down, and it's going to level off eventually at the horizontal asymptote. Same thing here. It's kind of looping down, but what's it got to do now? It's got to come back up, doesn't it? Because it's got to go to that horizontal asymptote. So this is definitely a little different than any of the previous ones we've done. But Just the way the points worked out. Is it okay? And notice once again, I didn't cross the vertical asymptote, but did I cross the horizontal? Yep, right there. I crossed the horizontal. So you can cross the horizontal asymptote. You just can't cross the vertical. Here's another example. Is that okay? Any questions on that? Okay? All right, let me